Hello, everyone, and welcome back to another installment from our series Straight from the Horse's Mouth. thinkstep-anz worked with New Zealand telecommunications company Spark on a report about the role digital technologies can play in reducing carbon emissions. Meeting the climate challenge through digital technology shows that technology can reduce annual emissions by 7.2 million tonnes by 2030. Equal to 42% of the emissions that New Zealand needs to reduce over this period. Here's a sneak preview.
And we also know that digital technology can enable cross-sector transformation. But in New Zealand, it's fair to say we've not been very deliberate in exploring the full extent of how digital technology can be applied to emissions reduction. And to date, there hasn't been a lot of conversation about the role of our sector in addressing climate change in New Zealand. What we found was that digital technology enables a variety of actions that could collectively reduce annual emissions by 7.2 million tonnes by 2030. Just talking you through the slide a little bit and breaking that down because there's quite a lot in there. We said earlier that New Zealand set its first emissions budgets. They act as stepping stones or interim targets to us reaching the ultimate goal of zero carbon by 2050. And as you can see in the graph, by 2030, we need to reduce emissions by about 17 million tonnes. That's against the 2019 baseline. To bring this to life, the biggest single saving we modeled was a saving in reduced light vehicle transport. And that was a 1.5 million tonne saving that we modelled. And that some of that was a top-down assumption, some of it was bottom-up modelling of actual use case. So amongst that was 400,000 tonnes saving from remote working. Another big barrier to EV adoption beyond the price is concern about availability of charging infrastructure, particularly when it comes to remote areas. So one of the use cases we modelled is what we did with FNX, and that's rolling out improved IoT network coverage in rural areas, which can increase the availability of charging infrastructure, which needs to be connected.
The report focuses on sectors that emit the most carbon in New Zealand: transport, energy and industry, and agriculture. Learn how digital technologies can reduce emissions in these areas. While this webinar focuses on New Zealand, many findings apply to Australia and the rest of the world. With that, let's get started.
Hello, and a very warm welcome back to our webinar series, Straight from the Horse's Mouth, Insights from Experts in 30 Minutes. My name is Emily Townsend. I'm Head of Lifecycle Strategies at thinkstep-anz, and I'm your host for the next half hour. Today, we're joined by Tom Newitt, from Sustainability Leader at Spark. It's great to have such a big audience today, and some of you might not know us. So just a couple of words about us. We are passionate about enabling organizations to succeed sustainably, and we help with detailed studies like materiality assessment, green financing, carbon footprinting, and LCA or more strategic sustainability projects. We've been doing this for 15 years in Australia and New Zealand. We've been really pleased to partner with Spark on this important study for Aotearoa, New Zealand. Like Spark, we're a member of the Climate Leaders Coalition, a group of New Zealand businesses working together to reduce their carbon emissions. And we're also an enabling business, providing organizations with credible science-based data and analysis to quantify greenhouse gas emissions and understand where to focus their reduction efforts, and then to help them tell their story. So as I mentioned, we've been really pleased to partner with Spark on this study. It shows the huge role that digital technologies can play in moving the country to a prosperous, low emissions economy in a way that's socially fair. When the government released their National Emissions Reduction Plan in June, it focused on proven and existing technologies. In this study, we've used data to understand the sectors and solutions where digital technology offers the greatest potential to help us decarbonise as a country. The report's a starting point. It's all about inspiring collaboration and focus for our collective efforts. And it's got national implications. So we're really excited to be part of the conversation and including sharing the findings with you all today. Our guest today, I already mentioned, is Tom Newitt. Tom's worked in sustainability and corporate responsibility for the past 15 years at organisations including Fonterra, Vodafone, Westpac, and the Department of Conservation. At Spark, Tom's previously worked with us to establish a verified science-based target. And with plans in place for their own emissions reductions, we were able to shift the focus to countrywide impacts. So with that, Tom, I will hand over to you.
Firstly, I want to start by thanking Emily and ThinkStep and Shanji for working with us on the study. They're always a lot of fun to work with, and we really appreciate their expertise when it comes to looking at, I think, things that are on the sort of cutting edge of sustainability and sort of outside the norm of what companies usually ask for in terms of help. Also wanted to start by touching on why Spark did this piece of research. So we're a digital technology infrastructure company, so we've got this big important role in investing in infrastructure and technologies that enable changes. But we know that that change doesn't happen by itself. It's people that harness the power of technology to make change. So we know we've got this important role to share the possibility of these technologies and connect people with what's possible so that we can then make sure we take the full potential of them. So the focus here is really on how can we use digital technology to address the challenges around climate change. I'm anticipating everybody on this call knows about the challenge of climate change and the context, but just briefly, we know the time to act is now, and the window to take action to avoid the worst impacts of climate change is closing quickly. So this is going to require rapid action and transformation across all sectors of the economy. And we also know that digital technology can enable cross-sector transformation. But in New Zealand, it's fair to say we've not been very deliberate in exploring the full extent of how digital technology can be applied to emissions reduction. And to date, there hasn't been a lot of conversation about the role of our sector in addressing climate change in New Zealand. I'm aware there are quite a few people on the call from Australia as well, so I think some of the context does bleed across. But this was very much in the context of New Zealand's emissions budgets and New Zealand's emissions reduction plans as well. So many of you will be aware that the government launched our first emissions reductions plan and budgets earlier this year. And as Emily said, the first emissions reduction plan was very focused on existing technologies and known solutions. And that was absolutely appropriate because we don't want any excuses not to start acting now. We're not waiting for new technologies. Those technologies are available. So that's right. But we also know that in the background, digital technologies and new technologies are evolving. They're converging, and it's unlocking new use cases that can support decarbonisation. And some of these technologies could enable us to move quicker or move cheaper than existing technologies as well. So although it's right to be focusing on what we can do now, we do also then need to be looking that next step out to make sure we're investing and laying down the right foundations so that those opportunities are open to us in the future. Before going any further, it's also important to acknowledge that we need to focus on our own footprint. So this isn't the digital tech sector looking to see what it can do elsewhere and not being responsible for its own footprint. We need to get our own house in order. And I think Emily mentioned that we've done a science-based target with ThinkStep and a webinar on that around 12 months ago. So if you're interested in what we're doing within our own business and our own sector, have a look at that. And we know that every business has to play a role to meet New Zealand's emissions reduction target. And our focus, most of our emissions is from electricity. So a big focus on energy efficiency and particularly enabling that transition across to fully renewable energy. So that's a big focus. The focus of this study is slightly different, and that's on opportunities for our industry to enable emissions reductions in others, but that's not excusing our own footprint and need to focus on that as well. When it comes to the study itself, there have been quite a few international studies over the last decade or so looking at this opportunity. Some of them have been specific to Australia as well, so Telstra and Fujitsu have done some work there too, but nothing's really been specific to New Zealand, and we've got a very high share of emissions that are due to agriculture, a very high share of renewable energy production in terms of electricity. So we've got some kind of unique factors which meant those things haven't been able to don't quite map across the same way. So we have to look and see how that applies to New Zealand. Luckily in New Zealand, with the Climate Change Commission modelling and their pathways and all the work that's been done around the emissions reduction budgets, we now have some very high quality models and assumptions that we can then transpose some of those global assumptions across to, and then look to see the difference it can make in New Zealand. So that's been a key part of the research we've done. Another part has been ThinkStep's got a lot of first-hand experience modeling and working with businesses applying sustainability solutions. And then Spark ourselves, we've got first-hand experience day-to-day working with businesses who are applying technologies and using digital technologies to solve problems, including many sustainability problems as well. It's particularly in the IoT space of our business, it's growing a lot of connections around monitoring and things like that. So we've got all this, bringing all that knowledge together, the top down, the bottom up. And what we really want to do with the study is not create some talking points or create a report to sit on the shelf. This is the first step in an action plan, really, in a roadmap for how our sector can step up, show leadership, and really make sure that the full potential of the digital technology is brought to bear in terms of addressing climate change. So this is all about action and what comes next. And we've been thinking about how can we accelerate, how can we remove barriers, how can we really make sure we make the most of this opportunity. It is worth covering up front before we get into some of the numbers, how digital technology enables emissions reductions. That's because an important part of this research is actually raising that awareness and growing people's understanding of the opportunities that are there. And I think most people think of number one in this infographic around connecting people when they think about digital technology, particularly in the telecommunications sector. And we saw when everyone was thrown into lockdown around COVID, firsthand how technology enabled us to keep working and keep connecting from home. So there is a big enablement factor there, but that's really just the start of the carbon enablement. Through technologies like IoT, we can also connect things other than people. And by doing so, that allows us to measure and monitor what's happening in the physical and natural world around us. And from that, we can then create insights from the data, which allow people to make informed decisions. Or we can use technologies like AI, artificial intelligence, to allow systems to make those decisions for us and really drive efficiency and smart decision making. When we come to number 4 there as well, we know behavior and behavior change and people are really important in terms of climate mitigation. So through digital platforms, through sharing tools, through connecting people, through social networks, we can encourage that behavior change and inform that decision making and create that momentum as well. And lastly, when it comes to number 5, a lot of what we talk about in climate mitigation is mitigating emissions in existing sectors. There's a big role to play in terms of decarbonising, creating new low carbon jobs, driving innovation, underpinning, and digital technology can underpin the creation of new low carbon industries as well. So that I think is important, and it's a sort of it's a way that digital technology can perhaps be a bit more optimistic about opportunities in the future rather than sectors that have got legacy issues that they've got to mitigate and invest in to reduce emissions from what are already high emitting sectors. Not going into too much depth on the technologies because I myself am not an expert on all the digital technologies, and I think it was a steep learning curve for Emily, Sanjeev, and myself as we went through all the interviews. The things like Internet of Things, you've got your sort of humble mobile phone, which is quite a rich and connected device as well. Internet of Things, artificial intelligence, and mobile access edge computing, which was something we had to learn about. All of these are the technologies that can unlock some of these use cases, which can underpin this, which can deliver this. Underpinning it, there are foundations we need to realize the benefits, and we need to continue to build on the strong foundations. And if you think about this, if you've ever done integrated reporting and used the integrated reporting model, these are almost the capitals we need to draw on to enable the change, the inputs we require. So digital infrastructure, capability, digital equity, supportive regulatory environment, and funding and capital investment. So we had a really wide view of technology's role in enabling a low carbon economy, a low carbon New Zealand. That was what we used to model the findings of the study. We've just got some climate change here, just a massive weather bomb hitting Auckland. That's nice, if you can hear rain in the background. So into the results of the study. What we found was that digital technology enables a variety of actions that could collectively reduce annual emissions by 7.2 million tonnes by 2030. Just talking you through the slide a little bit and breaking that down because there's quite a lot in there. We said earlier that New Zealand set its first emissions budgets. They act as stepping stones or interim targets to us reaching the ultimate goal of zero carbon by 2050. And as you can see in the graph, by 2030, we need to reduce emissions by around 17 million tonnes. That's against the 2019 baseline. So the emissions we've modeled, 7.2 million tonne reduction, is equal to 42% of that reduction required to meet the carbon reduction target. So that's really to give a sort of sense of scale. I think there's a degree of estimation, and it's always modelling, but we wanted to give a clear understanding of how much of a contribution we could make in the background. You know, these aren't digital technologies emissions, but they're emissions that we support the enablement of the reduction of. Bit of a tongue twister there. So that 7.2 million tonnes was modelled from the bottom up, extrapolating use cases that are on the ground already in New Zealand, and some of those top-down things transposed across to our footprint. And because we've taken that approach, this isn't additional to the things that are already in the emissions reduction plan, but it's probably taking some of those things that are in there and attributing it and understanding that they are digitally enabled. And there are also a few new things in there as well, which weren't captured in that modelling. So we've broken those savings down by sector. I don't know if you can hear okay, but I've got rain slamming against the window. We've broken these savings down by sector, with the most significant opportunities are in the 3 largest emitting sectors. So that was 2.9 million tonnes transport, 2.4 in energy and industry, and 1.9 in agriculture. And the reason we looked at the opportunities sector by sector like this, because that's how they're reported in our emissions reductions inventories, emissions inventories. as a country, and that's also how we've structured the emissions reduction plans. So if we're talking about engaging across sectors, there are the vertical sectors, which are the main emitters, and we're a horizontal enabler, really, that works across. So this is probably the easiest way for us to understand who we need to engage with and what kind of opportunities there are there. There were some other opportunities we identified in other sectors down the right-hand side there. They weren't considered to be as material. We didn't have data to model them. So they're just noted, but they weren't included in the numbers in the study. And so we can dive in and look at each of the sectors in turn and have a quick overview there, starting with transport, which was the biggest sector we modeled in terms of emissions reduction. So there's a lot to digest. There is more detail in the report, so I recommend looking at the report if you want to get more into the detail. Today's just a quick once over and a quick overview, giving some examples and some case studies as well. So in transport, digital tech enables emissions reductions in a number of ways. So we can reduce the need for travel outright through remote work and access to e-services like e-commerce or e-health. We can enable things like car and ride sharing as well, optimizing business fleet, freight logistics, enabling a smart integrated transport system. And we can also help accelerate the EV transition, and that's through improving rural connectivity and charging infrastructure, and also smart charging infrastructure as well. So to share an example to bring this to life, the biggest single saving we modeled was a saving in reduced light vehicle transport. And that was a 1.5 million ton saving that we modeled. And that some of that was a top-down assumption, some of it was bottom-up modeling of actual use case. So amongst that was 400,000 tons saving from remote working. And to give you an idea of the approach we took, Statistics.anz produced statistics on the amount of home working that was enabled, and when we went into the COVID-19 lockdown, and almost 1 million New Zealanders were able to transition to working from home through that time. So mapping that out to 2030, we're not assuming 1 million New Zealanders will work from home full time then, but what we have assumed is that 50-50 probably will move to a hybrid working system. So those who can work from home are likely to work 50-50 from home is what we've assumed. So taking a conservative, but I think quite realistic assumption, given what we're actually seeing happening now across many businesses. So that's where that 400,000 tons has come from. And again, we've accounted for the reduction in commuting emissions, but also accounted for increase in emissions in the home, powering the home with the MFE factors that have been published on that. Switching to energy and industry. Energy and industry is electricity production, and then industrial processes and things like coal and gas burning as well in homes and in industrial settings as well. So in these sectors, technology supports decarbonisation in a number of ways as well. So one of the ways we modeled was reducing IT energy consumption through centralised cloud infrastructure. And there is a real saving to be made there, but we haven't counted that towards the 2030 projected target, because we can also see there's lots of growth coming in data centers and cloud as well. So there is a one-off migration, but we're not counting that because we know that as cloud grows, it enables more services. It actually enables a lot of the emissions reductions we're talking about. You know, Zoom's a cloud-based service, and we're using it today, and we haven't traveled because of that. But the background infrastructure is also growing along with the value of those services. So we think it's going to net out to close to zero. We've got improving efficiency of commercial and residential buildings through smart connected systems. Reducing the need for large-scale centralized facilities through digital services. For example, if you think about offices shrinking in the future, or e-health services are available at scale, and switching consultations to online, you'd need fewer or smaller physical clinics and health centers as well. And then through industrial process automation and optimization. So to share another real-life example, in New Zealand, the Clean Car Discount program has been successful and encouraging more New Zealanders to consider electric cars. But another big barrier to EV adoption beyond the price is concern about availability of charging infrastructure, particularly when it comes to remote areas. So one of the use cases we modeled is what we did with EVNEX, and that's rolling out improved IoT network coverage in rural areas, which can increase the availability of charging infrastructure, which needs to be connected. Extrapolating that out to 2030, we modeled that could deliver 410,000 ton saving by 2030 when that's applied nationally, in terms of helping overcome those barriers and accelerate the EV adoption. With this case, we also model the benefits of technology capabilities that have next chargers that are used in homes and businesses. And in New Zealand, with our high share of renewables, managing energy demand at peak times is really important to reduce reliance on thermal generation, which tends to kick in more at peak times, and we're renewable as baseload most of the other times. So that's going to become even more and more important as more EVs are rolled out. So their chargers are able to shift load to off-peak times so that we can then keep up with that energy demand through renewable generation rather than needing thermal peakers. And modelling that in 2030 with the number of EVs that are likely to be on the roads, that we projected 100,000 tonne saving by 2030 through that technology as well. And that's one of the examples where digital technology often cuts across sectors, because this is a saving in the energy sector and the electricity generation sector, but it's also helping deal with an unintended consequence of the decarbonisation of the transport sector. So I think the energy system and the transport system is going to become much more connected, and to make it much more connected in a smart way, digital technology will be a key enabler of that. The final sector we modelled was agriculture. So in New Zealand, it's our most significant source of emissions. And there's lots of different future scenarios that have been modeled by different groups. So it's the hardest of the three to model from a digital technology perspective. And there are lots of technologies and choices on offer to farmers. And we think the key opportunity is really providing information and data on the drivers of emissions on farm, so that they can then use that information in order to make decisions with the limited resources they've got. So we know digital technology is just one part of a larger systems change that needs to come. And in our modelling, we've been quite conservative and tried to only capture the areas of change that are appropriate to account for from a digital technology perspective. But this is the area where the biggest savings are likely to need to come from, and the biggest variance in the government's projections are as well. So our view is that the key opportunities for digital technology in agriculture are mostly around enabling precision agriculture, and that's using data to inform decisions to improve efficiency. So enabling data collection and monitoring of multiple environmental, physical factors. That's enabling automating systems and actions for precise use of farm inputs, and informing decisions to improve farm efficiency by optimizing use of things like fertilizer, feed, and so forth. So for the purpose of the study, we chose 4 precision agriculture case studies and modeled the benefits that would be realized if they are applied nationally. We've just taken a carbon lens across all of the benefits here, but in agriculture particularly, I think precision agriculture's got benefits in water quality, it's got benefits in biodiversity, it's got benefits in animal welfare and food quality. So we've just taken a carbon lens, but we know that there are much more benefits that can be realized through the application of digital technology in the sector. One of our case studies talks to that broader role pretty well. So Spark, under the Spark group, we've got a data analytics business called Curious, and they work with a partner called MyEnviro, and they've developed a data-driven digital platform that farmers can use to better understand their environmental profile and report this to those they need to, for example, to regulators. So MyEnviro records changes in the farm's environmental management, and it digitizes farm environmental plans and integrates real-time verifiable data analytics on things, important data points, things like soil health, water quality, and so on. So the MyEnviro team's now working with Adroit, which is another business connected to the Spark group, to apply their real-time water and soil moisture sensors, which are connected over our IoT networks. And so by getting this real-time data connected to a data analytics platform, it enables the delivery of cause and effects insights, and it gives much richer and enhanced decision-making support to farmers as well. The possibilities, though, if you think about that farm example, they go beyond just those 3 sectors. And many of the solutions cut across multiple sectors. And we've just talked about climate mitigation as well. Climate adaptation is also something that technology can contribute towards. And we've recently launched a partnership with Christchurch City Council and Fire Emergency New Zealand, which is a good example of this. We do have a video to show which kind of brings it to life, so it's worth just sharing. I think the sound will work, but please flag if it doesn't. I will just hit play now.
New technology to help prevent and fight forest fires is being trialled in Christchurch. In a New Zealand first, 5 sensors have been installed at Bottle Lake Forest Park to monitor conditions and alert authorities in real time. Katie Stevenson explains.
Scenes like these are what authorities want to prevent. Homes destroyed, hundreds of hectares burned, and a life lost in the 2017 Port Hills fires.
There was such devastation from that event. We started thinking, what can we do in terms of using technology or different approaches to make sure we're aware of fires at the earliest possible point?
They're trialling these 5 sensors installed by Spark to monitor weather conditions across Bottle Lake Forest, another area that's been hit by fires in the past.
In the units, we've got 360-degree thermal imaging with AI capability. We've got video and still imaging, and we've also got a range of environmental sensors that detect things like rainfall, wind speed, and air quality.
All useful data points when coordinating a response.
It allows us to get real-time information about what's happening on the ground, allows us for the appropriate resources to actually be dispatched.
The public can access the information too through an app.
One of our team use it quite often to check if the pollen count is too high so he can bring his son here who's got allergies.
And it could address one of the lessons from the Port Hills fires, the need to get information out sooner.
To allow them to implement their community escape plans to ensure that the whole community is kept safe.
The trial will run for 12 months and the council hopes to expand it to include 3 sensors on the Port Hills too.
We're really interested in the potential that it has on the whole east coast of the South Island in terms of climate change and kind of challenges around wildfires. We think this is part of, the solution going forward.
A solution that could very well save lives. Katie Stevenson, One News.
That's just one example. If you can imagine extrapolating that out from beyond forest to connecting other parts of the natural environment and then connecting that to things like power systems, roading systems, and then making all that data open source so that people could then innovate, make decisions, and automate systems off the back of it. You can see the sort of power that technology could provide to help decision making and help climate adaptation and mitigation as well. I will just quickly touch on the social side of it because it's really important. There's the important social element to this as well, because digitization is accelerated through COVID-19, and that's demonstrated the importance of digital equity, particularly in times of change and transition. So this all links into the just transition, supporting communities to transition away from carbon-intensive activities and providing them good quality jobs in low emissions sectors. And unfortunately, at the moment, around 1 in 5 New Zealanders do have one form of digital exclusion. So that needs to be a real focus for us, because we don't want digital exclusion or worries about social inequity to be a barrier to adopting technology or transitioning our economy and reducing emissions. But equally, we don't want those transitions to be something that drive further digital inequity and social inequity as well. So there needs to be a real focus on that through the Just Transition strategy. The government's also got a digital strategy which includes actions towards this, and that's something we're working hard in the background. But in some ways, actually overcoming some of the social barriers to these technologies is one of the most important things we can do to make sure that they're taken to their full extent. Recommendations, I recommend reading the report if you want to see the full set of recommendations. And again, given that I've run over time, I won't go into too much, but the key part of the report was the recommendations and what do we do next. So there's a few different sets of recommendations for policy, digital to our own sector and businesses and other sectors. Two to just touch on quickly was the question for all of New Zealand, thinking about the data required to make decisions and automate systems in the future, and thinking about what kind of national system we might need around that so that we have a platform that everyone can access and everyone can use to make decisions and drive innovation from. I think that's a live conversation, but it's really important, and it's a barrier to a lot of these technologies actually being used at the moment is walled gardens around sets of data. And for Spark, the most important thing for us is to keep on sharing the findings, continue to raise the profile the role our industry can play with all of our different stakeholders. And we're aware the next set of emissions reduction plans is coming, probably being shaped over the next year with the Climate Change Commission and then into government for the year after that to be embedded. What we really want to do is make sure that digital technology has been considered in terms of the long-term planning picture so that we ourselves can invest in the infrastructure and invest in the technology that can enable that change, but then also sectors can bring that into their planning so that we're not missing any opportunities and that we're preparing the best we can for the future. Because I think it's that kind of that collaborative approach and everybody playing their role and each industry understanding its role, bringing everything together that's actually going to deliver the change we need across those different sectors. On that, I think I will close off and hand back to Emily for questions.
Thank you. Huge amount of information to put over in a short amount of time. I think one of the points that really stuck out for me this time was that the way that digital technology isn't just cross-sector, but helping to connect sectors, and the importance of that. I think that's really key, and leading towards that. Well, the whole point of this is to spark those conversations and collaborations. So I might kick off by asking what impact there's been so far, and how, have you been contacted by a flood of people asking for how they integrate digital technology?
It started a lot of conversations. So one of the first conversations, we launched the research with the Prime Minister and the Minister for Climate Change, and our CEOs since presented the findings to the, I won't get the name right, the CEO Climate Change Board, which is the CEs and DGs of the different government departments, looking to see how government can take the findings, which is fantastic. We have had a lot of interest from, it got really good media pickup, which is great. And I think what that's highlighted is that our sector hasn't had a lot to say about climate change so far, and this is really filling a gap, identifying a gap, and I think a gap that was acknowledged by the Minister for Climate Change in the emissions reduction plan, and the thinking around that next generation of technologies. And it's right that we focus and do what we can now, but we also need to think to that next horizon. And I think that's highlighted a lot there. I think the onus is on us to go out to those sectors. Those sectors are building their own roadmaps. The SBC's being very helpful to us in terms of the work it's doing with those sectors, and just asking how we can support, how we can connect in, and what it is collectively we can do to make sure that digital technology is built in, and so they can understand what the opportunities are for them, and we can understand what our responsibilities are to help enable that.
Yep. Great point. Thanks, Tom. I have a question coming from Bernadette. So about whether Spark invests in emerging digital technologies being developed in New Zealand.
I believe we do, and this is one of those one of the questions I'd like to throw across to one of my people in the tech side of the business. And the most recent example I can think of, it was our 5G Innovation Fund. So we had an open fund, and sustainability was one of the criteria. So funding business ideas that could use 5G technology, but they'll use it for the benefit of New Zealand, including with a sustainability angle. So that would be one of the platforms we've done to do that. But yes,
yeah. I think there's also a huge amount of investment into existing digital technologies, but the rollout of them, and the rural broadband initiative, is that the right one?
Yeah, rural broadband is it's one of the recommendations, and it was the recommendation in the National Emissions Reduction Plan. Was to make sure we continue to grow that coverage into rural areas, so that there was opportunities for precision agriculture there. Yeah, I think the interesting thing for us is that we're an infrastructure provider, technology provider, but a lot of these things are delivered through partnerships. And there's a kind of ecosystem of startup or smaller, more agile businesses out there innovating, and it's us supporting them and partnering with them that really drives innovation.
Yeah. And a great point added by Julian Newman. I don't know if he is with Spark, because he mentioned that Spark often co-invests with clients on specific projects as well. So preempting you, he is with Spark. Thank you, Julian. This is very interactive. Wonderful. A question then from Roll. Can we explain how this is measured? And I'm not sure, Roll, if you were asking how we've come up with the original estimates, or how we would track it going forward. But Tom, I'm going to throw that to you to start with.
Man, I might throw it back to you, because I think that we're our modelers on this. So how it's been modeled, not measured, let's say, has been on a 2019 baseline from our national inventory reports, and then looking at a 2030 scenario, which is provided by the Climate Change Commission around, we've taken things like what, and they modeled a number of different pathways. We took the demonstration pathway, which is kind of the one in the middle. How many EVs are we likely to have? What's the emissions factor likely to be? And then Emily, you can help with this, but it's what's the situation? What would the situation in 2030 be without the digital technology interaction? And what would it be with it? And then measuring the difference. So it's the difference that digital technology would enable or make.
Yeah, absolutely. And I think in terms of measurement going forward, the important thing is that New Zealand as a whole reduces. This isn't about them pinning it and saying digital technologies achieve this. It's really about highlighting the opportunity that people may not be aware of, and to drive that change. That's fair.
Yeah, it's quite a hard thing to account for, and it was the same in the modelling, because we've assumed there's going to be fewer vehicle kilometres travelled by people. So did the Climate Change Commission. There's lots of different ways that could be driven. Some of them might be digital, some might be not. And what will be reported and measured nationally will be the outcome, the output, rather than how it's caused. But this is about us understanding where we've got the opportunity to drive it, and which bits we can drive the reduction.
Yeah, great point. Question that's coming from Tim about skills, which I know you'll be pleased to hear about. So what workforce skills are needed to support the growth of digital technologies? And is Spark or other telcos working with education providers to ensure that this skill mix exists, or perhaps with businesses?
Yes, we are. I'm trying to remember all the different partnerships we're working on. And if I was not been so focused on climate change, I'd be able to give you a better answer. But so the Tech New Zealand has done a study in terms of skills that are required. We're working with academic providers. We're looking at also, I think a key thing for us is around digital equity, as well as diversity and inclusion in those tech careers, the types of people that are coming through and types of people that have opportunities for these types of roles. And if you look at the impact of climate change in a just transition view, a lot of that's regional rather than national. And you have, particular high impact industries are focused on particular regions. So it's about reskilling from a regional perspective as well, and getting down to a community level. But yes is the answer. I could give more information if you wanted to reach out to me afterwards and connect with the right people. It's connected into our people and culture teams, our HR teams, our training teams, and also the Spark Foundation does a lot of work around digital skills and digital pathways too.
I think there's also, it doesn't do all of it, but there's a huge amount that comes with growing up in a digital world as well. And I know it's one of the areas that you highlight in the digital equity is some of the older generation, not all by any means, struggle a little bit with accessing some of those technologies. And so that cross-generational thinking as well is helpful. I think that might be it for today. I'm very conscious that we've gone over. So thank you very much for everybody's attention and attendance. And there's been one, I tell you what, last question, it's just come in. Can't avoid it. Can we elaborate on Spark's IoT products used for energy efficiency and energy management? Or do you want to throw that to your technical team to come back with separately?
Yes, probably, to give a proper technical answer, because they are the technical experts. But the probably the most basic and most prominent one is just energy metering. So smart meters, giving a half-hour reading of every location in New Zealand. So that data at the moment is used for billing, but and it's starting to become more visible to the end user to drive behavior. But if you could get greater visibility of that and connection of that to things that were incentives to drive behavior change, you could see when you were using that energy, when the energy was most expensive, if you were thinking about half-hourly billing. And also there's availability of data in terms of the emissions intensity of energy now on a half-hourly basis as well. So you can get down to an individual house level or business level or location level, understanding every half an hour the decisions you could make to reduce costs and reduce emissions. So just even smart metering and connecting smart metering into the ecosystem, connecting it to your EV charger, your heat pump, those kinds of things, and enabling the whole energy system to automate and optimize itself is where the opportunity expands out to. But there'll be far more IoT options in there. If you're thinking about energy, fuel is energy, fuel optimization, fleet optimization as well. There's many different ways it could be optimized, and automating systems, digital twinning, looking at industrial processes. I could go on, but if you're interested in a L4 roll down, and potentially we've got a innovation studio in Auckland as well, where these technologies on display, please get in touch.
Fab, great answer. Thank you, Tom. I think with that, we will draw the proceedings to a close. So yes, thank you, everybody. And I'm going to attempt to seamlessly share my screen again. So thank you, everybody, for your attention. The webinar, of course, has been recorded and it will become available on the website soon. And you will have seen that we have another webinar coming up next week that might well be of interest around circularity. So a bit of a subject change, but make sure that you register. Thank you very much and have a great afternoon. So Tom, thank you very much for your time.
Thank you.